Good morning. How are you all? We are going to be doing our final lesson of Module 5. I know there's several other lessons that we're going to do, but we are only going to take it up to Lesson 17. And then when we start tomorrow, we'll be on a new lesson, which I will tell you about tomorrow. All right, so your first job is to watch the Eureka video for Lesson 17. You're going to find that this is very similar to what we did yesterday, so another day of practice with subtracting across zeros. And as you do the word problem, I am going to tell you that it is 2 steps. It is a 2-step problem. And at this point, I'm not going to tell you anything more than it requires 2 steps to do this problem. And we'll go over it in just a few minutes. Make sure that you use cubes and read, draw, and write as you solve that problem. Then you are going to move on with the problem set after, of course, you've watched the video. You are going to solve vertically, or if you can, using mental math. You're also going to be using the chip model because it is provided for you, and unbundle as necessary. So you're going to do problem A, B, and C, and then you're coming over to the next page, and you are going to do D and E. And then you have problem number 2. You are looking at solving 600 take away 367, which you are going to do in this box. And then you are going to check your work using this box. And I will remind you about your number bond, 600. And we have one part that's available, which is 367, and you are finding the other part, the missing part, and that should help you in your quest for checking if you remember bibbidi bobbidi boo. I think you can handle that. Once you've done that, then you are going to check back with me, and we will go over all of those problems together and check for your understanding. And then after you've done that, of course, you know that you need to do your exit ticket and send that to your teacher. And with that, I will remind you to watch the Eureka video first, then come and do the application problem, the problem set, check with me, and then you can do the exit ticket and send it to your teacher. And with that, I am going to ask you to pause the video, and I will see you in a few minutes for checking. Are you back? All right, here we go. Let's start by reading our problem. We always start with the read part. Colleen, who is one of the characters in our word problem, put 27 fewer beads, 27 fewer beads on her necklace than Jenny did. So that tells me that Colleen is not going to have as many as Jenny. Colleen put on 46 beads. How many beads did Jenny put on her necklace? All right, and then it also says if 16 beads fell off of Jenny's necklace, how many beads are still on it? So I'm going to just draw a little line here because this is really a 2-step problem. I'm going to have to solve this part of the problem first before I can find out how many beads are still left on Jenny's necklace after 16 fell off. Because right now, I don't know how many beads are on Jenny's necklace. I need to figure that out first. So I am going to divide my paper into 2 parts, and I hope you did that as well. And I'm going to solve that first part about finding out how many beads Jenny had on her necklace. And then after some fell off, that 16 fell off, we'll go back to that in a minute. We'll try to figure out how many she still has left. So let's see what we know. Colleen has 27 fewer beads on her necklace than Jenny did. Colleen put 46 beads on her necklace. I know Colleen is going to have fewer beads than Jenny, so I'm thinking that Jenny here is going to be my whole. I'm trying to find out how, whoops, sorry, I put that in the wrong spot. going to try to find out how many beads Jenny had, because she's going to definitely have more than Colleen. And I do know how many Colleen had because it told me that Colleen put 46 beads on her necklace. This is Colleen or Colleen. And I was also told that she had 27 fewer than Jenny. She had 27 fewer than Jenny. So I know that this is a part and this is a part. And if I add those two parts together, I will find out the whole, which is Jenny. So let's make our equation. 46 plus 27 will tell us how many beads Jenny has on her necklace. That's an easy problem to solve. Let's set that up. I'm not going to use the chip model. You can if you need to, but I'm not going to because I like new groups below because it's faster. So 6 plus 7, or 6 ones plus 7 ones is 13 ones, and I'm going to have to compose a 10. 13 ones is the same as 1 10 and 3 ones. 4 10s and 2 10s is... Okay, we are, sorry about that interruption. We have 4 10s plus 2 10s equals 6 10s plus 1 more 10 gives me 7 10s. So I know that Jenny put 73 beads on her necklace. Well, that was an easy problem to do. We're getting really good at these. She put 73 beads on her necklace, so I know that my solution here is 73 and that Jenny has 73 beads. That's what I was looking for. Alrighty, so she has 73 beads. Now that I know how many beads Jenny has, I'm pretty sure that I can now solve the second part of this problem, which is if 16 beads fell off, so I've got some going away from Jenny's necklace, how many beads are still on it? Well, that should not be too hard because I can see that that is going to be not too tough because I already know how many beads are on Jenny's necklace. I just found that out. Remember that from our last problem? I just found out right there that Jenny had 73 beads. And I know they told me that 16 fell off. And I need to know how many are left. What does she have left on that necklace? Oh, well, I understand this because this is just like a number bond. 73 take away 16 equals the unknown, or how many are left on her necklace. Well, I know how to subtract because we've been practicing it for such a long time. I cannot take 6 ones. Oh, I need to take a close look at that. 6 ones from 3 ones, well, just not going to happen. I'm going to have to decompose a 10, which is leaving me with 6 10s. That decomposed 10 is now 10 ones. 10 ones plus 3 ones equals 13 ones. 13 ones take away 6 ones is 7 ones, and 6 10s take away 1 10 is 5 10s. Woohoo! That was pretty nice. I know that she has 57 beads left on her necklace, and that's easy for me to write. 57 beads are left. Oop, my F didn't work out too. Left on her, or Jenny's, necklace. Woohoo! And if you got both of those whoops, I guess I better push that up a little bit. If you got both of those problems correct, you should give yourself a big, huge smiley face, because if I was there right now, I would be so proud of all of your hard work. You have come such a long way as a second grader. I can tell that you're getting ready to be a third grader. All right, let's go ahead and look at the next problem that you needed to solve. It looks like we're going to have to subtract across some zeros. I've got 200 take away 113. 200 take away 113. I know that I'm going to have to show my whole in my chip model. So there's 200, and no 10s and no 1s. So I know that I'm going to need to take 3 1s away from, well, there's nothing to take it away from. And there's nothing in the 10s, so there's only one place to get that from, and that's going to be my hundreds. So I'm going to decompose 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I've decomposed 100, leaving me with 100, and now I have 10 10s. Whew. All right, but that still doesn't give me enough 1s. In order to take that 3 away, I'm going to have some 1s. So let's decompose a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've now decomposed that 10, and that leaves me with 9 10s. All right, that's easy. And now I have not 0 10s anymore, but 10 10s. 10 10s take away 3 10s. Well, 1, 2, and 3 leaves me with 7 10s. 10 10s take away 3 10s is 7 10s. All right, so now I'm into my 10s. I have 9 10s, and I'm going to take away 1 10. 9 10, take away 1 10. Well, let's see. Let's take away 1 10. That leaves me with 8 10s. Way to go. Now, let's see. That's perfect. Now I need to come over into my hundreds. I have 100 left, but I need to take 100 away. So oh, you know what I forgot to do? Miss Star, 9 10s take away 1 10 is 8 10s. And now I'm taking away that 100 right there. 100 take away 100 gives me 0 hundreds. So if you came up with 87 as your difference, wow, I'm hoping you're getting lots of smiley faces on your paper. I am really hoping for that for you. Okay, so I am just wondering, did you get 153 as your difference for letter B? If you did, you should give yourself a little smiley face. I'm going to work this problem without using the chip model and see how I got that 153. 247, I'm going to do it without the chip model just to show that it can be done that way. So I'm taking a close look at 400, and I know that I cannot take 7 1s from 0 1s, but I don't have any 10s either, so I'm coming over into my hundreds. I'm going to decompose that 100. That will leave me with 3. That decomposed 100 is now 10 10s because, well, 10 groups of 10 is the same as 100, but I still don't have enough 1s over there, so I'm going to decompose again. That leaves me with 9 hundreds, and instead of having 0 1s, now I have 10 1s. 10 1s take away 3 1s. 7 1s is 3 1s. That answer just always comes into my head, and then it comes out before I should say it. 9 10s take away 4 10s is 5 10s, and 3 10s take away 3 hundreds take away 2 hundreds is 100. I see how I got that. Of course, I can do that with the chip model as well. Let's do it. I'm just doing it a little bit different today because I want to practice using that. No 10s, no hundreds. I'm going to have to take away 7. So I don't have enough to be able to take 7 1s away from 0 1s, so I'm decomposing that 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now I have 10 10s, but I'm going to have to still decompose 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, I think I can take away those 7 1s now. Let's do it. 1, 2, 3, 4, 5, 6, 7. That left me with 3, and now I have to take away 4 1s. 1, 2, 3, 4. That left me with 5 1s, and now I'm going to take away 2 1s. 1 and 2. That left me with 1. No matter how I do it, whether I do it in the vertical model or I do it in the chip model, my difference is still going to be 153. And congratulations if you successfully did both of those steps. I think I'm going to do that again. I kind of like that way. Let's go 700. We're going to do it with the new groups below first, because really that is the fastest way to do this. And I will do it with the chip model just in case that is still a method that you need to use. But hopefully you're getting to the point where you don't need the chip model anymore. So let's take a close look at our whole. And I can already see that I can't take 8 ones from 0 ones, and there's no 10s. So I'm coming over into my hundreds. I'm going to decompose 100. That leaves me with 6. That decomposed 100 now has a value of 10 tens. 10 tens, that's great, but I still don't have enough ones, so I know I'm going to have to decompose a 10, which will leave me with 9 tens. That group of 10 is the same as 10 ones. So I think now I'm in a good position where I can subtract all the way across. 10 ones take away 8 ones is 2 ones. 9 tens take away 2 tens is 7 tens. And 6 hundredths take away 4 hundredths is 2 hundredths. If you came up with 272, congratulations, you are doing a fantastic job. I will show the chip model just for those of you who need that chip model. 100, 200, 300, 400, 500, 600, 700, 0 tens and 0 ones. I cannot take 8 ones away from 0 ones. And I have no tens, so I'm going to have to decompose 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to have to decompose another 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now I can take 8 ones away. 5, 6, 7, 8. That left me with 2. Oh, that's where I needed to go. Now I'm taking 2 tens away from 9 tens, 1 and 2. That's leaving me with 7. And now I'm taking 4 hundredths away from the 6 hundredths that I have left. 1, 2, 3, and 4. That leaves me with 2. So regardless of how you do this problem, if you can do it without doing the chip model, congratulations to you. And you are getting strong math brains. If you still need to use the chip model, that's fine. You can, but it certainly is faster to use new groups below. All right, I'm going to continue what I was just doing on that page. And let's go ahead and do 800 take away 606. I'm going to do new groups below, and then I will come over and do the chip model. All right, because I'm hoping with all the practicing that we're doing that you're feeling more comfortable with new groups below. I cannot take 6 ones away from 0 ones, and I have no tens. So that means I'm going to have to decompose 100, which will leave me, hang on here for just a second, that will leave me with 7 hundredths. Now I have 10 tens, which is the same as 100, but I still don't have enough ones. So I'm going to have to decompose a 10. That will leave me with 9 tens, and that decomposed 10 has a value of 10 ones. 10 ones take away 6 ones is 4 ones. 9 tens take away 0 tens is 9 tens. And 7 hundredths take away 6 hundredths is 100. If you came up with 194 and you could do it without the chip model, congratulations to you. But if you needed the chip model, well, you can still use that. Let's do the chip model for 700, 100, 200, 300, 400, 500, 600, 700. Don't have to draw any tens, don't have to draw any ones, but I cannot take 6 ones away from 0 ones. So I'm going to have to decompose that 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Whew, still don't have enough ones. Going to have to decompose again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew. Now I can take away 6 ones. I'm going to quickly take those 5 plus 1 more leaves me with 4 ones. Hopefully you're getting so you can do it without this. 9 ones I'm going to, or 9 tens, I'm taking away 0 tens, so that's easy. I still have 9. And now I'm going to take 6 ones away from 7. 1, 2, 3, 4, 5. Sorry about that. I just noticed that I had a little boo-boo. 1, 2, 3, 4, 5, 6, 7, 8, and I decomposed. That left me with 7. Sorry about that. And now I'm taking away 6 100s. 1, 2, 3, 4, 5, plus 1 more going away leaves me with 1 100. Boy, I just noticed that boo-boo. Shame on me. Try to be a little bit more careful, Miss Star, but if you make a boo-boo, just go back and fix it. Even though I've been teaching for a long time, I still make boo-boos, and I just forgive myself and move on. Now let's try letter E. We have 901, and we are going to be taking away 404. 901, take away 404. I'm going to do the chip model second because I'm really hoping that you are feeling confident with new groups below. All right, so taking a close look at my whole, I cannot take 4 ones away from 1 1, and I have no tens. So I'm going to decompose 100, which is going to leave me with 8 hundredths. Now that I've decomposed 100, that gives me 10 tens. 10 tens, but I still don't have enough ones. I still am going to have to decompose another 10, which will leave me with 9 tens. That 10 is the same as 10 ones, plus the 1 1 that's already there gives me 11 ones. 11 ones take away 4 ones is 7 ones. 9 tens take away 0 tens is 9 tens. And 8 hundredths take away 4 hundredths is 4 hundredths. Whew. If you came up with 497 and you could do that without the chip model, I'm going to give you a great big huge smiley face because that is where we are trying to go. But if you still need the chip model, that's okay. 10, 20, 30, 40, 50, 60, 70, 80. Oh, sorry, I counted that wrong. 100, 200, 300, 400, 500, 600, 700, 800, 900, no tens, and 1 1 for 901. All right, so I am going to be trying to take 4 ones away from 1 1. Can't do that, don't have enough. Have no tens, so I'm going to have to decompose 100. Now I can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Whew, still don't have enough ones. Decompose a 10. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now I do have 11 ones, and I can take off 4 of those. 1, 2, 3, and 4, leaving me with 7. Now I'm coming over and I'm noticing that I am taking away 0 tens. That leaves me with 9 tens because I don't take any away. Now I'm coming into my hundreds and I'm going to take away 1, 2, 3, and 4. 4 from 8 hundredths is 4 hundredths. Whether you do it with the chip model, the new groups below, or you can do it mentally, your difference is still 900 or 497. And as I said, if you can do it without the chip model, congratulations. All right, so now we are going to solve 600 take away 367, and I am not going to be using the chip model. If I do, I'm going to have to get a piece of scratch paper to do that, and I'm not going to do it. I'm hoping you're feeling comfortable enough that you can do it without. All right, so I can't take 7 ones away from 0 ones. I have no tens, so I'm going to have to come to my hundreds, decompose 100 to get 5 hundredths. All right, so That gives me now 10 tens. There's my 10 tens, but I still don't have enough ones. So I'm going to have to decompose a 10, which is leaving me with 9 tens, but now I have 10 ones, and I can start subtracting. 10 ones take away 7 ones is 3 ones. 9 tens take away 6 tens is 3 tens. And 5 hundreds take away 3 hundreds is 2 hundreds. Whew. If you came up with 233 as your solution to this subtraction problem, that your difference is 233, congratulations. But now we are going to check. And I am thinking about my number bond. I know now, oops, dropped my pencil. I know now that my other part was 233. That makes checking pretty easy because of bibbidi bobbidi boo. I know that if I add my two parts together, I'll go back to my whole. So let's do 233, which is right here, one of my parts, and add that to 367, which is my other part. And if all goes well, I will come back to my whole. 3 ones plus 7 ones is 10 ones, with a composing a 10 ones, or 1 10 and 0 ones. 3 tens plus 6 tens is 9 tens, plus 1 more 10 is 10 tens, and I composed 100. And 2 hundreds plus 3 hundreds is 500, plus 1 more 100 gives me 600. And boy, am I happy that I got the whole back. Congratulations to me. And if you were able to do that as well, congratulations to you too. Don't forget that when you have a number bond, your part plus part equals your whole. 600 take away a part will give you your opposite part, and so on. Whew, that was a lot of work. Now, your job is to do the exit ticket, woohoo, and send that to your teacher. And with that, I hope you have a fantastic day of learning. Bye-bye.